So hello everyone, let us solve another GfG problem, and the problem name is kth element of two arrays. So you are given two sorted arrays A and B and an element K, and your task is to find the element that would be at the kth position of the combined sorted array. So what the question is saying that you are given two arrays, array A and array B, and both of these arrays are sorted, and you need to find the kth element if you combine these elements of A and B and form again the sorted order. So let's say in A you have elements 1 and 2, and in, let's say, not 1 and 2, 1 and 3, and in B you have element 2 and 4. So these both are sorted in itself. So let's say k value is given to as 2, so you need to find the second element of the combined array A and B. So combined array would look like 1 2 3 4, and since you need to find the second element, so 2, you will return this 2. So this is what the question is saying. So this problem solution is similar to the median of two sorted arrays. Median of two sorted arrays. The same logic will be applying here. Yeah, I will explain the solution obviously, but yeah, if you are familiar with this problem, it would be easier for you to understand this problem as well. So like, you can just solve this question and come to this question again, or you can just solve this question and then solve this median of two sorted arrays. These are one of the same kind of problems. Same solution will be applied in the both of the problems, same logic I mean. So yeah, let us discuss how will we find this solution with the help of this example one. So obviously, if you look at the time complexity of this particular problem, it is logarithmic of base 2 of minimum of like size of array A and B. So let's say the size of array A is n and size B is like array of size B is m. So this is what the expected time complexity is. And obviously, if you are given the term as sorted, you would obviously think of the binary search, and by looking at this time complexity also, we'll be getting the idea that we need to apply binary search, because there is some kind of searching related, and also the information says that the arrays are sorted, so obviously we will be going for binary search approach. So let us see how we can solve this problem with the help of first example. So this is the first example that they have given. So actually, what I'll be doing, whatever solution I will show you, there will be one condition that will be applying to the smallest array, the binary search, because if you look at the time complexity, we need to have the minimum of n and m. Now even though it is not given, it is better to apply binary search on the smaller size, because it will handle lot of complexities. So even though you can see the example, A is 2 3 6 7 9 and B is 1 4 8 10, so I have just swapped these arrays because I want to apply binary search on smaller size array. So this will be our A and this will be our B. So yeah, just this little bit information that I want to provide before starting on to the solution or the approach. Yeah, so this is our array A and this is our array B, both in sorted order. So yes, this is also sorted and this is also sorted, and you can see like both of the arrays are sorted. So their combined would look like this: 1 2 3 4 6. So 1 2 3 4 6, then 7 8 9 10, 7 8 9 10. So this would be the combined output. And since the k value is given to us, what was the k value? The k value is 5. So you need to return the fifth element in this combined order. So the fifth element is this 6, so you will be returning your answer as 6. So this is what the question is saying. But how will we solve this? Now if you observe this particular scenario carefully, what you will observe that now obviously this is in the sorted order, so obviously this half will be lesser than this half, obviously, because it is in the sorted order. Now what we need to take care is that how many elements do we need to take from this array A and how many elements do we need to take from this array B in order to get the correct result. So if you look at this particular scenario, this is the left half and this is the right half. So if you just like take what all elements are from array A, so these are the elements that are from array A and these are the elements that are from array B. So 1 and 4 are from array A, so I have just written 1 and 4 here, and 2, 3 and 6 are from array B, so I have written this just below that. Similarly 8 and 10 are from array A and 7 and 9 are from array B. So you can say that this is the right half and this is the left half. Now in this scenario you can see that left half is always lesser than this right half, obviously because it is in the sorted order. So we know that okay, this 4 will be lesser than 8 and 6 will be lesser than 7. We know that for sure because these are the elements from array B only and these are the elements from array A only. So this is for sure. But what makes this case useful, because this 4 is lesser than 7 and this 6 is lesser than 8. So whenever we find such scenarios, let's say we give this name as L1, we give this name as L2, for this we give the name as R1, and for this we give this name as R2. So what will be the validation condition? Because we know that our answer is lying with this formation only. So obviously this is the valid condition and our validation condition depends on this scenario L1 R2 and L2 R1. So what is the validation condition that we need to check? So let me just write down the validation condition. So this condition is nothing but when your what is this, L2 is less than equal to R1 as well as L1 is less than equal to R2. So that means at that moment you find your valid order, like how many elements you have taken from A in the left half and how many elements that you have taken from the left half in array B. So this is the valid scenario in which you can say that okay, this is the correct formation that we want from array A and array B, and now we can get the kth element. Now obviously our kth element will be either the last element of A or it would be the last element of B. So what we can do? Because why last element? Because you can see that from array A we'll be choosing 2 elements and array B will be choosing 3 elements. So combine array A will have 2 elements and B will have 3 elements. So total elements that we have in left half is what? 5 elements. So our fifth element would be obviously residing in either the last part of A or the last part of B. So what we can do? We can simply return. So whenever we hit our validation condition, we can just return maximum of what? Maximum of what? This is what? L1 and this is our L2. So whenever we hit the validation condition, we can say that okay, we need to return whatever is maximum from L1 and L2. So this is the validation condition. So I hope you now understand how this solution will be working. But still, how will we decide how many numbers to take from A and how many numbers to take from B? Now that's where we'll be applying the binary search. So we'll be applying binary search in the array A or the smaller array, which is in our case would be this array of 1, 4, 8, 10. And what we will do? We will have our low value and we will have our high value. High value will be nothing but the last index of array. Now this is not the actual case, there is edge cases as well that I will discuss in the code, but for now just to understand the basic idea of the solution, I am just showing you the like with respect to this example. We'll discuss the edge cases as well in the code. So our low value will be starting from 0 and high value will be 3. Why? Because low value is here 0 in A and the maximum value or the maximum index in A is 3. So we will make our cut, where we will say that okay, we will choose this many elements from A and remaining elements from B, array B. So we will calculate the cut one. Cut one is nothing but how we calculate the middle element. So low plus high divided by 2. So we get our cut one to be 1. That means from array A we need to pick one element. And the remaining elements, what are the remaining elements? K minus cut one. So these remaining elements that we will be taking from array B. So you pick one from array A and you pick 2, 3, 6, 7 from array B. So how this scenario would look like, let me just show you. Yes. So this is how this scenario would look like. So you have array A, one element present, and array B, 2, 3, 6, 7 element present. And the remaining elements are as follows from array A and array B. Now we need to check our validation condition. What was the validation condition? Our L1 should be less than equal to R2, as well as our L2 should be less than equal to R1. So this element is R1 and this element is R2. This element is L1 and this 7 is L2. Let us check whether this validation condition meets or not. So L1, which is 1, is less than equal to R2. So okay, L1 is less than equal to R2, this condition gets fulfilled. Now L2 is 7 and R1 is 4. So L2 is 7 and R1 is 4. So no, this condition doesn't hold true. That means it is not fulfilling our valid condition, validation condition. So that means this combination of selecting array elements from A and B is not valid. Now if it is not valid, where should we go? Either we move towards left or we move towards right. So let us check. So if you see that this 7 and 4 are the actual problem, this 4 should be towards the left part and this 7 should be towards the right part. So how we can make our 4 towards the left part? That means in order to move our 4 towards the left part, we will move towards the right, because if we move towards the right in the array A, then only we will be able to cover more elements, and in order to cover this 4 we need to extend our window. So what we will do, not window, actually the search part. So what we will do, we will just update our low to be cut 1 plus 1. This is nothing but what we do in mid plus 1 in normal binary search. So now our new low value will become 2. So now how will we apply the binary search again? So our scenario would look something like this. Our low value is 2, our high value remains same 3. So our cut 1 will be what? 2 plus 3 by 2, that will be 2. And what will be the cut 2? 5 minus cut 1, that is 3. So this is our cut 1, that is 2. So we will take 2 elements from array A and we will take 3 elements from array B. So this is what our scenario would look like. So yes, this is the scenario. 2 elements from array A and 3 elements from array B. Now again we will check the validation condition. What is the validation condition? This is L1, this is L2, this is R1 and this is R2. So our validation condition was what? L1 should be less than equal to R2, as well as L2 should be less than equal to R1. So let us check. Our L1 is 4 and our R2 is 7. So our L1 is 4 and R2 is 7. So yes, this condition is fulfilling. We need to check the other condition. So L2 is 6 and R1 is 8. So again, this is also satisfying. So both of these condition is satisfying. So that means our validation condition is fulfilled. That means this arrangement of elements is perfect. That is 2 elements from array A and 3 elements from array B. So that means this is the valid condition. So now we will be able to find the kth element in the combined sorted order. And what will be the kth element? Kth element will be nothing but maximum of L1 or L2. So in this case L1 is 4 and L2 is 6. So maximum will be 6. So we will be returning our answer as 6. And if you just look at the output, yes, the output is also 6. So this is how we'll be solving with the help of binary search this particular problem. And the time complexity is nothing but, since we are applying binary search, so it will be of log base 2. And what would be the searching space? It would be minimum of size of array A, let's say size of array is A dot size is equal to n and B dot size is equal to m. So the time complexity will be minimum of n comma m. So this will be our overall time complexity. Now why we are doing the search in the smaller array size, to just reduce our complexities. So yeah, this will be the final time complexity. So let us see the code now and let us discuss few other edge cases as well. So let us see the code. So yeah, this is the code. So initially I have declared the array A size as n and array B size as m. Now this is just the condition to just swap if the size of array A is greater than array B, because we need to apply binary search on the lesser size. So we are just swapping both of the arrays to get the to apply binary search on the smaller size part. So this is what this condition is doing, nothing else. Now from here our main logic starts. First we'll find the low value and high value. Now low value will be maximum of 0 comma k minus m. Why k minus m? Because it can happen that your k is greater than m. So in that case you must select some elements from A, then only you will be able to select total of k elements. So you can't select 0 element in this particular scenario if your k is greater than m. So that's why we are initializing our low value with maximum of 0 comma k minus m. Similarly for the high part, you need to take either k elements or n elements. So it can happen that your k value is less than n. So in that case you need to select minimum of k comma n. So these were the edge cases that we are taking, and few other edge cases as well, just to take care of the max value and min value. That is, you'll understand why we are doing that. So this is the main binary search logic. So we'll do this until the low is less than equal to high. So first we are finding the cut1 value and cut2 value. Cut1 value will be nothing but low plus high by 2, and cut2 value will be nothing but k minus cut1. Now what will be the value of L1? L1 will be nothing but a of cut1 minus 1. You can just visualize from the array that we have chosen in the drawing explanation part. This is self-explanatory. And similarly the cut L2 value will be nothing but b of cut2 minus 1. Similarly for R1, the R1 value will be what? A of cut1, and R2 will be what? B of cut2. Again, this part is the self-explanatory. You can just check the example test case that we have taken. You will able to understand how these values are coming. Just from the visualization you can understand. Now why we are taking the int mean value and int max value? Just to handle the edge cases if we are choosing no elements from L1, no elements from L2, no elements from R1, so and so forth. So in that case, what will be the value of L1? So we are just initializing with int min, so that when we compare it with R2, we have this validation condition fulfilled. So that is why we are taking int min and int max value in case we are not choosing elements from either array A or array B in either left half or the right half. So this is the last edge case that we need to take care. Now the conditions are very easy. This is the validation conditions. If our L1 is less than equal to R2 and L2 is less than equal to R1, so just return maximum of L1 or L2. Otherwise, if our L1 is greater than R2, just move the higher to the cut1 minus 1, else move low equal to cut1 plus 1. So the condition that we have seen in the drawing explanation part. So again, this is the same logic that we have seen while dry running on that example. The same scenario, either this will happen or this will happen. In the end, if you don't find the answer, simply return minus 1. So yeah, this was it about the problem. So I hope you understand the solution. Thank you for watching.